We have a fantastic panel today, and very, very interested in hearing the discussion on carbon capture. We've got panelists Parag Kulkarni from GE Vernova, Mike Matson from the Boston Consulting Group, and Tom Pavia from ExxonMobil. So, guys, I'm just going to go down the list and let you introduce yourselves. Maybe Parag, starting with you.
Absolutely. Hey, good morning, everyone. My name is Parag Kulkarni. I'm serving as the Executive Engineering Manager for Carbon Capture Solutions for GE Vernova. And my team and I, we focus on reducing the impacts of decarbonization on gas power plants. So I'm very excited to be here. Go ahead.
Thanks, Parag. And thanks, everybody, for the invitation. It's exciting to be here. Mike Matson, I'm a partner and associate director with the Boston Consulting Group. For those that aren't familiar, we're a management and strategy consulting firm. I sit at the intersection of energy and climate and sustainability and focus on low carbon solutions. Probably pertinent to today's discussion, my background prior to BCG was actually the US part of CCUS. So I cut my teeth as a PhD chemist going into upstream oil and gas. I did what's known as enhanced oil recovery, which for those that aren't familiar is using compressed CO2 to effectively dry clean old wells and squeeze out a little bit more oil. And then eventually use that skill set to pivot into carbon capture and storage or sequestration, so the S part in CCUS with a startup called Carbon America. So real excited to chat together.
Good morning, everyone. Thank you as well for having me. I'm really looking forward to the discussion and the questions and the engagement. So my role, Carbon Capture Technology Ventures Manager, I actually sit in the low carbon solutions part of the business within ExxonMobil. The technology ventures piece of it is the role in point source capture specifically. So we have technology programs. We're looking to develop and bring new lower cost solutions. So I'm over that within the business part of the organization, trying to make sure it's market backed and has clear targets and we're driving towards the objective. So I work very closely with the technology organization to bring solutions to market.
Great. Well, as previously mentioned, a very qualified panel to talk about carbon capture here today. So guys, thanks for joining us and committing your time to be here. I actually only realized this a little while ago, but three of my former employers are represented on the stage here. That's probably not a total coincidence. But you've each of your respective organizations have, I think, treated carbon capture as a strategic initiative. And I'm curious to just, give us your perspective on, why each of your respective organizations felt that carbon capture was strategic to your company, to your organization. Maybe this time, Tom, if it's okay, I can start with you and you can take that one.
Great, yes. So I actually like to start first with broader objectives within ExxonMobil and then work into CCS because they all link very closely together. It's very foundational, and it starts from what we like to call the AND equation, and that's our goal is to provide energy and reduce emissions for the world. And we think of a successful energy transition moving forward, it's going to need reduction in emissions from affordable technologies so that we can supply energy and bring billions of people out of energy poverty to increase the standard of living. So it starts at a very high level from that. It works into low carbon solutions in my role. And really what we're doing in low carbon solutions is we're wanting to bring new carbon reducing technologies to market for customers. So where are we focused on those solutions? It's hydrogen, lithium, and CCS. So that's the CCS piece. And the reason we are focused on those is it fits with our core capabilities and where we think we can bring a lot of capability to market, build on that, and bring solutions. So what do I mean by capabilities? Technology integration is a big item that we worked on through many years. Subsurface technology, that's a key part of CCS. And then also large projects. We've demonstrated our ability to deploy and successfully start up large projects. So those all come together. So part of the question being there in terms of the market. So who are we targeting and why are we bringing forward these solutions? Our focus area is on the industrial emitters Think of steel, petrochemical refining, power generation. When you look at that, that represents 80% of global emissions. It's a large amount of emissions in a large market. And so the combination of where we can bring our capabilities and then this large market is why we think CCS is one of the items that we can bring and that should play a key role in decarbonization. Great.
Well, thank you for that perspective. Mike, maybe over to you and BCG's perspective.
No, absolutely. And hard act to follow. I think from our perspective, I'm actually going to steal a quote from you yesterday on, what disease are we treating? What's the urgency? It's climate change. I mean, without a doubt, that is where we started leaning into that. BCG is ahead of the curve in sustainability consulting, and we believe it's not only an imperative, but it's our right as a company, or our obligation, I should say, to ensure that we're helping our clients make those steps. And it's our belief that that doesn't happen without an economic model behind it. And so that's kind of what prompts a lot of it. If you go out and look at almost any reputable climate model and play scenario games on it, it's almost impossible, without the exception of examples where you just turn off fossil fuels tomorrow, which I personally don't believe is a possibility for mankind, to actually achieve any of our targets without carbon capture. And so that's what underlies it, why we see it as an imperative. For the audience, and just to make sure, because we're using a lot of acronyms and terms, but when we use CCUS, I'm referring to point source, so that's abatement. So I have something that's emitting carbon, I'm capturing it from that source. But there's also removals, and that can be in the engineered world as DAC, or direct air capture, pulling CO2 back out of the atmosphere that we've already emitted. And our models show that you need a combination of both to hit any reasonable target, that we need to both stop what we're, I like Bill Gates' analogy that he puts in his climate book, right? The bathtub of CO2 is filling up. We need to both pull the drain so that we're actually pulling it back out so it can drain down. That's the DAC. But we also need to stop it from filling up, and we need to push the lever on that. And so I think those are the reasons that we've leaned into it. And I feel that right now, and probably topical to today's discussion and the times that we're in, we're seeing energy demand growth. And I think there's a very strong push right now on how do we achieve that. There's a lot of low carbon solutions. I deal with these day in, day out. Great solutions, small modular reactors, geothermal. And a lot of those are ready today, but a lot of them aren't. And until they get there, I think that this is, for lack of a better word, back to what disease are we treating? This is the Band-Aid. This is the quick fix. And I think it's going to help us bridge that gap. So.
Thanks, Mike. Parag, maybe over to you on GE Vernova's perspective.
Absolutely. Thank you. So do I have the option all of the above?
Yeah, absolutely.
So all of the above. Plus, let me start by talking a little bit about GE Vernova. Actually, today, April 2nd, we are celebrating our first birthday as a new company. So it's exciting. So as you know, we spun off from GE Aerospace exactly 1 year back. And we like our chances, how things are turning out. Now, with that, with GE Vernova, we have tremendous history of 130 years of foundation. We make around 25% of world's electricity through our products. And our mission, similar to what was said before, is to electrify the planet, and at the same time finding out ways to decarbonize it. So it has both the elements of meeting the growing energy demand and at the same time being, fight the climate change. So when you think about that, all our product portfolio is more geared towards all of making electricity with the lowest carbon intensity, right? So when we think about decarbonization, is what is carbon intensity? It's amount of CO2 that you generate per megawatt hour, and you want to minimize it. So that's how we think about it. Now, we love renewables. We have wind turbines. We are developing the next generation nuclear SMR technology for the next decade, which is going to play a very important part on the decarbonization side. We have a lot of products today on the grid side for electrifying that help on the renewable side. But with all that, we truly believe that gas power has the potential today and farther midterm and long term in the future through the energy transition and even continue to move forward. And gas can be like one of the force multiplier to bring more and more renewable on the grid by providing that dispatchable supply. With that, and we can talk about the gas power demand over the next 2 or 3 years. But now when you think about how do we decarbonize combined cycle power plant or gas power, within that carbon capture becomes one of the prime pathways along with hydrogen. And when it comes to hydrogen, depending upon where the hydrogen is coming from, carbon capture is a critical part of that as well. So with that, as Mike said, there is no scenario that can go without CCS. So we are focused on that, but in the near term also, we are going to work with commercially available carbon capture technologies and integrate them better so that we can meet our mission, which is to provide the low carbon intensity for our customers.
Great. Yeah. Well, that's a good smattering from 3 industry leaders in terms of why this topic matters. So I think we can check the box and say, yes, it's important. And maybe move on to topic 2, which, as at Entropy, we're constantly looking at projects and trying to get projects to FID, final investment decision. And of course, one of the biggest challenges when we talk about carbon capture is cost. And so, the biggest driver, I think I heard it in all of your introductory remarks, one of the biggest drivers in driving costs down is technology. And so I thought maybe we could talk a little bit about technology advancement. And Mike, if it's okay, I'll start with you because you've got a lot of clients in this space and you get a lot of different perspectives. But what are the things that are out there, from an advancement perspective, technology perspective, that you're excited about that you think can really push this industry forward?
That sounds great question. So the incumbent technology right now is what we call amine treatment. For those that are not familiar, at a very high level, we run flue gas through a liquid. That liquid has a affinity for CO2, so it can bind to it, so it removes it out of the flue gas. I then take that saturated liquid with CO2 into another container. I warm it up, and when I warm it up, releases that CO2, and now I have pure CO2. I've got 3 experts sitting next to me that can talk to that ad nauseum, so I'll let them go into the advancements that we're seeing. And to be very clear, there are a lot of exciting advancements there in that tech. But I think one of the things that we're seeing there that's changing is modularity. So we are finding smaller systems that are making economics more competitive. A lot of that can be saving costs on the manufacturing. I think there's other technologies that are advancing right now, so I'd talk a little bit about those, both on the carbon capture side as well as on the utilization and storage side. On the carbon capture side, we're seeing the firm that I came from, Carbon America, they were a cryogenic company, and there's about 3 or 4 leading technologies there. Oversimplified, instead of using a liquid, they actually just change the pressure and temperature to form dry ice. So the CO2 is removed as a solid, and then you can melt that and inject that in a well. There are solid-based sorbents, companies like Svante, that are out there. You may have heard of things like metal organic frameworks, zeolites. These are very similar properties and act similar to the amine systems, except instead of a liquid, it's in a solid state. And there's some nuances there. But we're seeing advancements on that. And I think one of the other big ones that right now is really exciting is membranes, and we're seeing advancements there as well. So companies like MTR, like Ardent, Aqualung, they're advancing these technologies that will allow us to separate out those gases. I think on the other side of the equation, we can only get the costs so low on the carbon capture unless we get a big unlock, but usually that's going to be driven by energy inputs. Where we're finding a lot of the savings on these projects is on what do I do with the carbon once I've captured it. And so a lot of that depends where you are. Here in Texas, we're very advantaged. We're over a lot of what we call saline aquifer or subsurface geology that is really great to shove CO2 in. And I think the advancements that we're learning there are actually business advancements. The formation of hubs, for example. So if I have one hole in the ground and 10 plants are all sending their same CO2 to the same hole in the ground, you're diluting the cost of that hole in the ground across 10 projects, as opposed to, say, in the Midwest, we see a lot more one-to-one projects. There's one emitter, there's one hole. Well, it has to stomach the cost of that entire hole to inject. And I'm obviously oversimplifying that a little bit, but we're seeing advancements in these hubs and these clusters coming together. We're also seeing advancements in transportation. And I'll finish with that because I want to make sure we get other opinions. But I think what we're seeing there is we're seeing advancements just beyond pipelines, which traditionally is how we've moved it. And for scale, just for the room, we have about 2 million miles in this country of natural gas pipelines. We have 5,000 miles, give or take, of CO2 pipelines. So that gives you an idea of the scale of how different that is. And right now, if you've seen in the news, there has been some political push against pipelines in certain areas. And so there's been a lot of creative solutions trying to get around that. How can we safely transport this from point A to point B cheaply and effectively? So what we've seen advancements in rail. We're seeing class 1 train engines and companies coming on board to figure out how they can move it on rail. And a lot of these CO2 sources are already on a rail system. We're seeing barges looking at waterways that are flat. And we're also seeing offshore shipping. Think of projects like Northern Lights. And so the more advancements we get on all of these sort of technology buckets are going to lower those costs and make these projects more economic. But I'll pause there.
Great. Well, thanks for that overview. I appreciate it. Parag, you know this, that I geek out on exhaust gas recycle. And for those of you that are interested, Parag's done a lot of work on exhaust gas recycle on GE turbines. And I think you've even there's some public feeds that are out there that you've worked on as well. But maybe you can give us a little bit of your perspective on why GE Vernova thinks exhaust gas recycle is a key technology to help drive costs down for us.
Yeah, absolutely, Sanjay. And you mentioned public studies and public information. We recently completed a DOE-funded feed study on Southern Company Barry, and there's a lot of information on that if there is interest to look into the benefits of exhaust gas recirculation. More excitingly, we are also demonstrating EGR technology in the Net Zero Teesside project that is also out there in the public. So this project in UK is going to be most likely the world's first full-scale combined cycle power plant with fully integrated carbon capture, where around 2 million tons of CO2 is going to be separated from our 9H8 2 turbine, around 750 megawatt, and that will be put safely underground in the North Sea in north of UK. So going back to EGR, and by the way, I'm a chemical engineer too, and this technology excites me, right? So very simply what it is many of us have it in our older cars, 90s cars and things like that. It's when it comes to the combined cycle power plant, imagine taking part of the HRSG exhaust or gas turbine exhaust, cool it down, and put it back into the front end in the compressor. And you can do maybe 30%, 40% of the exhaust and put it back. What it essentially does is now you're replacing the incoming air or part of it with some of the exhaust. And there is a lot of technology that we have to take care of our gas turbines, and we're working on that. But why it is exciting for carbon capture companies is because it does two things. Now, because we are taking, let's call it 30% exhaust and putting it back in the gas turbine, the stream that is going to the carbon capture is only 70% now, so lower volume. And then at the same time, we are increasing the concentration of CO2. So let's call it like, a typical combined cycle power plant would have roughly 4% CO2 in the exhaust. You can push it with the right amounts of EGR to north of 6%, close to 7%. So it is getting more closer to the carbon capture technologies that are already demonstrated on coal power plant, it's in the 11, 12%, I believe. So you're now getting a more concentrated CO2 flow and then also the volume is lower. That ends up reducing the cost of cooling and the absorption as parts of the carbon capture plant. So if we can get these benefits, collectively you're going to see overall reduction in the capex. Also the OpEx, right? Because now that you have more CO2, and you probably all know the famous theoretical curve, right? The more CO2 you have, it's easier to separate it in terms of energy. So there is some energy benefits that come with it. Plus there are some operational benefits. So long story short, we see a lot of potential in there. And then, as I said, we have to keep on working on gas turbine technology to make sure that we can put more amount of, employ more EGR, because then we have to deal with the lower oxygen concentration in the combustion, and then how to manage emissions and dynamics. But it's very exciting. Our CEO has talked about it publicly as well. So this is one of the levers we can pull in to reduce the cost.
Indeed, yeah, no, and we're quite excited about it as well at Entropy. Maybe a quick follow-up for you. Is there any negative effect on the performance of the turbine with recycling the gas, and then also maybe give us a little bit of an idea of the cooling burden, because you have the hot exhaust gas, and what burden that might have on the economics of the integrated process?
No, a great question, right? So if you take the exhaust, which is coming out, maybe let's call it 170 Fahrenheit and above, you cannot just put it back into the gas turbine. So it's like taking a gas plant from, Canada to maybe Houston, right? Because you're increasing the temperature, right? Yeah. And that's not good for power, as you all know, right? The higher is the ambient temperature, the power loss is more. So you have to cool it down. So there will be a little bit of cooling load that is associated with EGR, and when we think about the overall benefits, that is taken into account. Now, the good thing is today's carbon capture technologies, they also like cooler gas, right? So anyway, we're going to bring it down to around 100 Fahrenheit or something like that. So it's not like it's lot more extra cooling, but then you can also do some trade-offs and figure out what's the right amount of cooling that is needed to get the overall benefit. So
yeah, great. Well, thank you for that. Tom, I'm going to turn to you with the same topic on technology advancement. Maybe give us, ExxonMobil's perspective on where, technology can help bring costs down. And in particular, I know that I think you, in particular, you manage the MHI relationship, or Mitsubishi Heavy Industries relationship. And I know that partnership is focused on technology advancement. Maybe give us a little bit of background on what y'all are focused on there.
Yeah, definitely. To start, collaboration. This is the discussion here with MHI is about collaboration. And I believe for the energy transition, collaboration is going to be a key piece of that, working together with multiple people. Like that must happen. So this MHI Alliance is an example of that. Not the only form of collaboration, but it's an example of one that we worked with MHI very early on. What the alliance is it brings together our capabilities, MHI and ExxonMobil, to offer a ready now solution for decarbonization. And that was one of the main, not the only one, but one of the main drivers for this alliance. So MHI has demonstrated liquid amine technology that Mike described there at scale. So if you look even in Texas, there's a Petronova, you could look it up after this, but Petronova is the name of the project. It's a coal-based power plant, and they put a large-scale 1.6, 1.7 million tons annually carbon capture facility. So that's what I talk about when I mention scale. It's very large scale. On the ExxonMobil side, we have 30 years of experience in capture, transportation, safely storing CO2. And so we thought bringing these two together to offer a solution that's ready now, again, like that was a key piece of it. Like technology demonstrated was a key piece of that. The second part was combining the R&D programs that both companies were working on to make carbon capture better, specifically in post-combustion liquid amine space. That's the target for that alliance. And so we wanted to bring the two groups together to have a concentrated effort focused on bringing down the cost and making it better, really with the objective to have more economic projects for customers. I mean, that's the end of the day our focus. So that's that's the purpose of the alliance and what we're doing, both on a commercial side and having a product, but also on the technology development side, two key pieces. And maybe just a touch for a minute on broadly on technology advancement. So I'm going to hit it again and again probably, and you hear it here, but it all comes down to having affordable technology solutions. And that's really where the key advancement needs to be in the space. And R&D programs like the one I mentioned, even university programs, I mean, need to continue to have that focus on how do we bring down the cost. And when I say cost, I mean total cost. I mean, we have a lot of focus on capital because the size of these projects are so massive, but it's everything. It's energy, capital, total cost. So we need those R&D programs. The other thing to me that I think is really key for working down, bringing new technologies to market that are cost efficient is learning and being able to implement it and learn from doing. And how do we actually facilitate that? So I think there are two ways. There could be more, but there are two ways that come to my mind. One is industries. Do we have industries out there that are willing to pay a higher cost to start while they know that we're going to work down and open up a larger part of the market? And then the second one I wanted to highlight is policy. So policy can play a key role, especially for these new technologies, early deployment. How can you support them with the goal that they're going to stand on their own, but the early deployments so you can learn from it and bring down the cost and making it accessible for everybody.
Great. Yeah, that's a comprehensive answer, and I could not agree with that more, including we're sitting here at the University of Texas. Yeah. I got to give a bit of a shout out to the chemical engineering department. I think a great example of collaboration is we're a part of the research consortium. I know ExxonMobil is as well, and there's a big degree of expertise in Chem-E here. I don't see Dr. Rochelle, but I see Fred here in really collaborating on technology and helping push the industry forward. So very topical here at the University of Texas. I'm going to switch. Hopefully the engineers have gotten their fix talking about technology. I'm going to switch to markets. And the next question is really about market potential for carbon capture. And maybe Mike, I'll start with you again because you see a lot of clients in this space. There's a very healthy outlook for power, growth in power generation and the power market. Maybe an open-ended question of, I think even if a fraction of that market goes towards carbon capture, we have a very healthy industry, and we're sort of, as Tom said, getting down the experience curve and really bringing the cost down. What are some of the things that you think need to be in place from a market adoption standpoint to get some of those dominoes to tip over for carbon capture?
No, it's a great question. I think a lot of that is going to be driven by consumer demand. I think that's going to be one. So we need to get to a point where these markets are driven by a desire from those that are buying this power to say, I'm willing to pay for decarbonized solutions. We have that. It's not overwhelming, but it is there. Good examples right now would be our hyperscalers that are willing to pay more for power on a green data center as opposed to a standard data center. I think the other thing that we need to think about as we go through that is timing. And I think that's the other area where carbon capture will really have a leg up. I think I kind of alluded to that earlier in some comments. But deploying today, it's really tough to get base load around-the-clock power on a lot of low-carbon solutions. And so CCUS, it's not the only lever, but it is one of the dominant levers. And so I think that will also help ensure that market development. And making sure that you've got speed to market. I think the third thing that carbon capture offers is which other solutions may not, in building the market, is a deployment schedule. And what I mean by that is that this technology doesn't necessarily need to be operational on day one. And so we will see scenarios where there will be deployed power that carbon capture can come in maybe on year 2, year 5. And there's actually FEED studies going on, front-end engineering studies that are going on right now to explore, well, what does that look like? How does a plant operate differently on day 1 capturing carbon versus on year 5 capturing carbon? And how do I tweak that and adjust that? So I think all of those sorts of factors from the consumer side will drive that. And I believe markets are going to ultimately be developed by those consumers. And then kind of piggybacking on some of the other comments, I think there's also something to be said about the policy support and the regulatory support that would go into that as well. So
Great.
Happy to expand on that or hand off the mic.
That's great. Yeah, I think maybe I'll go back to Exxon and Tom on this one. Market. I know your CEO, I think specifically was out there talking about providing baseload power, low carbon power to data centers, but more generically, maybe you can tell us about where you see adoption for natural gas generation with carbon capture in the market, and what the potential signposts or milestones are to know that we're going in the right direction towards market adoption.
Yeah, definitely. So to start, I want to come back to some of my earlier comments, though, in terms of, so we're talking here about natural gas power with CCS and supplying low carbon power to data centers. That's the overall item here. And tying on what I said previously, I do think this is a great example of the and equation, because what we're looking at is reliable power at scale with carbon capture. So the carbon capture will go and get at least 90% plus of the CO2 emissions generated from the power generation and store that. So we're meeting the needs and we're reducing emissions. That's the and equation we're talking about. The reason we're interested in this and looking at this is it comes back to some of my other themes on capabilities. And where we think we can bring something to market here potentially is we have experience in CCS. We have experience in integrating projects together, complex projects, and again, large capital deployments. Secondly, we have invested in and we have infrastructure in the U.S. Gulf Coast for CCS, so large pipeline system with for transportation and then also storage. And so those things come together, we think, and offer a potentially a compelling opportunity. When we're talking about baseload power, what we're thinking about this in terms of a decarbonization opportunity is actually putting this in, the projects in, and they would be independent of existing grid infrastructure. Why are we talking about that? Why are we interested in that independence from the existing grid infrastructure? There's two pieces that I'd like to highlight. One is the pace to market, the ability to get that in faster and supply the power quickly to support the AI growth domestically. The second piece there is that if you put this in behind the existing infrastructure, consumers wouldn't have to pay for grid updates. So you get those two key components. And then just quickly, I think maybe just to summarize, take the big picture here and look at it. We'd be starting from domestic natural gas, capturing the CO2 emissions, and then supplying low carbon power to support domestic AI growth. So I think it's a great story here on what we could do within the U.S. Gulf Coast and the U.S. to really build up that industry and reduce emissions.
Agreed. And for just going back to my talk a little bit yesterday, there's some people call it the energy trilemma. I called it the quadrilemma yesterday because I think it's got to be cheap, it's got to be reliable, it's got to be environmentally friendly, and it also needs to get to market fast. That was the fourth leg of the stool. And you can't get everything for free. So I think we all acknowledge it's going to cost a bit of money, but hopefully the consumers are out there that are willing to pay a little bit of a premium to get this market to go. Parag, I'm gonna ask you a little bit more broadly on a market because you have the unique perspective here of being at a company that's seeing a very healthy order book for turbines right now. And so just even broader than just carbon capture, maybe you can give us some insight from GE Vernova about what you're seeing in terms of drivers of power demand globally and what that means for your supply chain and order book.
Yep. Yeah. No, this is we're kind of standing on the brink of an exciting future here, right? I think currently our gas turbines are sold through 2028, taking orders beyond that. And that's typical for all the gas power industry equipment. Now, sometimes there is a fear that is this like a bubble back in 1999 that we had, which kind of popped in 2002. But we truly believe that this is more similar to the growth that we had in the US in around 1945, post the World War II. And every 10 years, the grid infrastructure doubled. So maybe not to that magnitude, but the amount of the investment super cycle that is happening, especially around the AI. And also, the reserve margins are falling. There is tremendous energy demand needed all over the world. So with that, I think we feel like over the next decade or two, the speed to market is going to be important, tremendous need for energy. And sometimes we may have to go into the solutions which are, deploy the power today, but keep the optionality open, as both Mike and Tom said, so that we can decarbonize them tomorrow. So we feel that this market is going to be there, and not only in the U.S., Canada. We see today in India, if you look at it, 1.4 billion people, 80% of the energy coming from coal, and that is slowly changing. So as those technologies move, as they move away from coal into solar or renewable other type of things in Asia, gas demand is growing, and people trying to find different ways to decarbonize it. So I think we can talk a lot more, but I know we're coming down to the question answers here. But happy to talk more after the event. Yeah.
Yeah, no, it's good perspective, and I think good time to be selling gas turbines.
Yeah.
Good time to be in the natural gas industry. And good to know that we can do it in an environmentally friendly way, too. Well, we've got 7 minutes left, and I want to open it up to Q&A from the audience here. So why don't we move into Q&A, and I'll invite anybody from the audience with a question for the panel.
Hi there. Talked to you yesterday about this, but also GE, I know, and Mike, obviously we know each other. But on the ExxonMobil side as well, when instead of coming off the natural gas and using natural gas, and I know GE's working on this as well, but using strictly carbon dioxide, CO2 in a supercritical form to create the energy and use that as the base of the energy. So the abundance of that energy is produced for electricity behind the meter. You can use the CO2 anywhere in the world, make up a microgrid, stand up a whole power plant in the middle of a desert. And I don't think there's enough focus on that. We know GE is working on those. We're sort of involved in part of that as well. Yep. And then bringing in the natural gas as a backup, especially to stand up like a data center, right? And we know that we can sequester the CO2, we can use that. But what are your guys' thoughts on shifting more towards that more heavily carbon dioxide used for power generation versus natural gas? Obviously, we know, I've been in the drilling business, drilled for ExxonMobil, lots, been drilling around the world. But also, Mike and I sit on another board together, has to do with CO2. So we're, I think there's some focus that we could, sort of teach everybody during these classes that CO2 is able to produce electricity, baseload electricity through geothermal wells as well. So, I want to see what your perspectives are on that.
Yeah, I can start if that's okay. So, a couple comments just immediately, and happy to discuss more afterwards. it starts from kind of where we're interested in and the opportunities we're exploring do tie to our capabilities. I kind of come back to that, like where we can influence and what we have capability to build on. So that's why we're focused on what we are. That being said, I also said collaboration is important and open to new ideas. So though that's our focus, I'm not admittedly super familiar with what you're offering or discussing, but I think open for just dialogue after and to see if there actually is something that fits with capability and development and makes sense. So,
sure.
Yeah.
Yeah, why don't we take that one to after the chat, and another question over there.
Hello, that was a great talk. My question is, could you please share your thoughts and potential advantages and disadvantages of the greening effect, which is the increase of area of leaves and vegetation due to the increased level of CO2?
Anyone, Mike, I don't know if you've given that one some thought. Maybe you can.
So just to make sure I'm playing that back, you're asking about the effect of increased CO2 causing more vegetation and what the effect of?
Increase of area of vegetation, because CO2 is a fertilizer for the plants.
Correct. And so the question here is, if we do CCS, will that decrease that aerial vegetation? Okay. We've had this question quite a bit, and I think where we've seen it the most is in the U.S. Midwest. This has come out from a lot of the farmers that have that concern. And there it's actually a combination of both CCUS and DAC. For the most part, what we have found is that the dilution of the stream in an immediate area is actually pretty minimal that we've been able to calculate on the impact of that vegetation. That we did a study once where, effectively, to your question, we went out and we said, we're increasing this volume of plants. If that decreases, we're getting the carbon dioxide removal to go down, right? Because there's less plants pulling that out of the atmosphere. So we tried to factor that in. It was a rounding error on the numbers. Like, cutting the emissions was that much more significant. That was one case example and one, like, off memory, off the cuff in a Q&A that I remember. I'm happy to explore that further with you, but I mean, just that's my limited knowledge on that one.
Okay, maybe time for one more.
Hey, thank you. Great panel. A lot of knowledgeable power generation people up there. Thought I'd take advantage of it for a quick question on sort of simple cycle versus combined cycle. Is this primarily NGCC being deployed, or are they in such a hurry that they're dropping in simple cycle units? And then part two is on aeroderivative versus frames. My understanding is, the older power gen was a lot of frame. Has it all gone to more efficiency aeroderivative, or what's the breakdown there?
I think probably, Parag, a good one for you.
Yeah, so I think when you think about decarbonization, the carbon capture technology is, as you know, more suited for combined cycle. If you start with simple cycle, and if you want to do post-combustion carbon capture, you have to cool it down and essentially kind of turn it into kind of a combined cycle. For simple cycle, you may have different pathways to get there, right? If you want to decarbonize, it might be like, especially if they are peakers, you can get low carbon fuels like hydrogen to work on it. And in terms of what our customers are looking for, I think it's a mixed bag depending upon what is their investment appetite, how the project is looking. So, but some of the big ones we are looking at combined cycle, but I'm sure there are a few of the customers who are looking into simple cycle. And Aero has its advantages, like, better operability, higher simple cycle efficiency. There are some cost challenges, so it all comes into the mix, and we see all of it. So that helps.
Mm-hmm. Yeah, Thank you. We've certainly seen a project or two where there was, simple cycle intended as backup that is now running actually as baseload, because of just availability. Yeah. Well, I think we're right at time, so I just want to take a brief moment to thank all of our panelists. I spent a lot of time in this space, and I can tell you this is a very qualified panel. We're very lucky to have them here at UT today. So Tom, Mike, Parag, thank you very much for your time, for making the trip.